This tutorial focuses on what we call projectile motion. Now, a projectile is an object that moves through space acting only by gravity, which is obviously pulling it down towards the center. So what are we talking about a projectile? Well, what it is basically if you take a rock or a ball and you throw it into the air, it's going to take a path like that. It's going to have an arced path. And that's simply because when you toss it up, it's going to have an initial velocity of something. And as it continues its path up, it starts to lose velocity up until it hits final velocity of 0. Now, we learned that when we were talking about free-falling objects, that when you're just dropping something down, it starts with a 0 velocity and then it gains velocity. Well, at the top of a throw, right when the object starts coming back down, we know that the velocity has hit 0 because it starts with velocity, and as gravitational force starts pulling on it, acting on it in the opposite direction, eventually this pull evens out, and that's the velocity will end up being 0. So then it has the path coming back down, and we know old age saying, what goes up must come down. Basically, it's because of this. Now, as it comes back down, it starts to regain velocity, and its velocity down here will be equal to what the velocity was to begin with. So say I toss up a ball with the velocity of 2.0 meters per second. Well, when it comes back down, that velocity here, if exactly at the same height as it was originally, will be 2 meters per second. So we can use this idea to calculate a variety of things, such as if something was tossed up straight up in the air, not at an angle, but straight up, we know that at the top of its height, of its throw, it's going to be 0 velocity in terms of velocity, and we can calculate turning it around as a free-falling object with initial velocity being 0, what the velocity would be at the bottom. With this in mind, we can also calculate things like the distance at which the height was done. Because if we time how long it takes for the object to go from here all the way over here, we know that at the midway point it was half of the time, and so we can take the total time, divide it by half, and just start looking at it as a free-falling object. So we're going to be looking at these in terms of just simply objects going straight and coming straight back down, or objects that are moving horizontally and getting thrown off something, as it would like an airplane throwing off a load. So what are the principal ideas? Again, we know that initial velocity at the top of its path will be 0, just the way we were with freefall. We know that the acceleration due to gravity is still 9.8 meters per second squared, and therefore we can calculate a variety of things. Now, regardless of the path, regardless of whether this is a path like this, or if it takes a really long path like that, or if it is just straight up and down like that, all of these have similarities to them. So we're going to look at the general rules that projectiles take. The general rules of projectile motion that we need to consider is the fact that horizontal and vertical motion are independent of each other. So as it's going across horizontally, that maintains a constant velocity. Therefore, the velocity this way is not affected. Another thing to consider is that the vertical motion, when it's launched parallel, we go back to a free-falling object. And so you have an initial velocity being 0 meters per second. And again, we have acceleration as negative 9.8 meters per second squared. Now, this is when things are being launched out of something going parallel to the ground. But if it is launched at an angle, we're going to look at how to calculate velocity by taking the initial velocity of the projectile. That means when you're shooting something up at an angle, like tossing a ball or something to that effect, we have initial velocity multiplied by the cosine of the angle at which it's launched at, and the vertical velocity would be the velocity, initial velocity, multiplied by the sine of the angle. And we'll look at more things that are being launched horizontal to the ground, and we'll do a couple of them that are being launched at an angle.